Hello everyone, my name is Ange SAHUQUET and I'm very happy to be part of the Solar Pumping Workshop 2024. I'm here to talk about photovoltaic pumping tests, a supervising tool for photovoltaic water pumping systems. This presentation is going to follow these summaries. About the context and proposition, so we have to know that photovoltaic water pumping systems are good candidates for the access of water resources in isolated areas. So let's talk about pumping tests. Pumping tests are done usually at the beginning of the lifetime of photovoltaic water pumping systems. So after drilling the borehole of the system, we're going to conduct what we call pumping tests. These pumping tests are a tool to evaluate the sustainability of groundwater resources. For this kind of test, we're going to extract water during a certain duration at a fixed flow rate. And we're going to measure the evolution of the water level inside the borehole. And it's going to give us information on the state of health of the borehole. And also, it's going to determine the maximum flow rate that we can fix for the extraction of water in this borehole. For that, we're going to use a diesel generator. This kind of test and can be realized only during the installation phase of PVWPS. It also has a certain cost and asks a certain logistic. After that, we're going to install the PVWPS and we're going to consider that the flow rates that we fixed during the pumping test are going to be sustainable for the whole lifetime of the system. It's why we are introducing photovoltaic pumping tests, which are kind of tests that are allowed to be done during the whole lifetime of the system using the solar energy that is at our disposition and only measuring the flow rate and the water level inside the borehole during one usual day while the system is still in operation. So this kind of test present many advantages. It allows us to have a continuous operation of the system because it's necessary so people can still have water. Through this study, we also develop indicators so we can evaluate the evolution of the state of health of the borehole. So now I'm going to just introduce the borehole water level that we are using through this study and also introduce the health indicator. So the borehole water level, HB, is the sum of the static water level and the drawdown, so the dynamic evolution of the water level inside the borehole. And the drawdown can be written as follow, which is extracted from the studies from Thomas Vezin. Let's introduce the borehole dynamic health indicator. We can be expressed as the drawdown simulated with a characteristic pumped flow rate on drawdown at the initial state of the system. By that, I mean with the results that we had during the installation phase of the system. Here is the quick definition of the characteristic pumped flow rate. So to implement this kind of test, we just need a flow meter to measure the pumped flow rates, and we need a water level sensor. Also, to do this protocol, we only need one technical operator. The protocol can be as follows. First, we need to install the equipment before the sunrise, and then we're going to collect the data from 30 minutes before the sunrise until 3 hours after the sunset. The idea is to have the beginning of the pumping while we still have the static water level inside the borehole, and then to have all the measurements until we reach again the static water level inside the borehole because it's the night. Then when we have all those data, we can remove the equipment and do the analysis. Let's talk about our case study and the results that we get. So this approach has been applied on our case study in Gogma in Burkina Faso, where photovoltaic water pumping system is installed for 218 inhabitants. So the results that we get are summarized in this table. From that, we identified the static water level, HBS, kappa 0, and mu 0. And we have an identification of those parameters that is pretty accurate. Then we compute do two indicators, the simulated drawdown. So we can see it's the idea with this indicator is to have something that is physically interpretable. This indicator allows us to evaluate the evolution of the state of health of the system. To conclude, this kind of test allows us to update accurately the parameters of the borehole and to identify if the evolution of the state of health of the borehole of a photovoltaic water pumping system. This kind of protocol is at interest for different stakeholders as NGOs, governments, companies, and also local authorities. Thank you everyone for your attention. Let me know if you have some question.